Today we are solving Leetcode question 208, implement trie prefix tree. A trie or prefix tree is a tree data structure used to efficiently store and retrieve keys in a dataset or strings. There are various applications of this data structure, such as autocomplete and spell checker. Implement the trie class. Trie initialize the trie object. Insert the string word into the trie. Search returns true if the string word is in the trie, that is, was inserted before, and false otherwise. Start with return true if there is a previously inserted string word that has the prefix, and false otherwise. Let's take a look at the example. So in this example, we first initialize the trie and then insert the word apple. After that, we search for the word apple. It will return true because we have already inserted the apple. And then we search for word app. The return is false. That is because, we have inserted the word apple, but we did not insert the word app. After that, we call starts with app. This time it will return true because apple, the previously inserted word, actually starts with app. Then we insert the whole word app. After that, we search for the word app. This time, the return value is true because there is a complete word corresponding to app that was inserted into the trie before. So now let's code our solution. So here indicates trie or prefix tree is a tree data structure. So for each tree data structure, we need to first define the node. So let's first define the trie node. So for the trie node, let's first initialize it. For the binary tree, which is the data structure we are more familiar with, the binary tree has left child and a right child, and then during the initialization of the node of the binary tree, we can directly initialize left child and right child. However, for the trie or prefix tree, it can have multiple children. So in this case, how do we store and keep track of all the children? So we use a dictionary. Then for every dictionary, we need to know, what is the key and the value? So here, the key is a letter or character. So that, for example, A. And then what is the value? So the value here is the corresponding trie node. So we have a children. It is a dictionary to store the children of this trie node. We also need to know for each trie node, does it corresponding to a end of a complete word? So for example, let's take a look at this given example. When we search app, when the trie contains one word apple, in that case, we can traverse down all the trie node from the root node, matching character by character A, P, and P. But when we stop at P, we check, does this node corresponds to the end of a complete word? In this case, no, because we only insert the apple, and then in that case, the return value is false. So in that case, for each node, we need to know if it's the end of a word inserted into the trie before. So in that case, self.isEnd equals false. So we use this to indicate if this node is the end of a complete word. So this is our trie node. Let's code the trie data structure. First, we need to initialize a root node. So the root node is just an empty string. And then let's code insert function. So for insert, we are insert the word character by character. And then we start from the root node. So in that case, we need to keep track of the current node we are at. Initially, the current node just points to the root node. and then we are insert character by character. So for each character in this word, we first check if this character has already been inserted into the trie before. If this character was not inserted before, so in this case, if this character not in current node children, in this case, we actually create an empty trie node. And then after that, we move to the next node. We are doing this by updating the current node. So now the current node points to the corresponding child for the previous node. And then in the end, after we finish inserting all the characters in this word into the trie, we mark the current dot is end equals true. So indicates, okay, this node corresponds to the end of a complete word. So that's our insert function. Now let's implement our search function. So for search, we are still search character by character, starting from the root node. So in that case, current node equals self.root node. And then we check every character in this word. If this character not in current.children, so in that case, we just return false. There is not a match. If we find a match, we continue traversing down this trie. We move on to the next node. So in that case, current node is updated to current node. In this case, the current node is updated to the corresponding child. And then in the end, let's say we reach the end of this word. So basically, search all the characters in this word. And then in that, we just return current dot is end. If the ending node corresponds to the end of a complete word, it will return true. Otherwise, it will return false. So for start with, it's very similar to the search function. So let me first copy paste the code. So in that case, we still first initialize the current node points to the root node. And then we are trying to search in this prefix character by character. If this character is not in trie, so we just return false. If it's find there is a match, then we move on to the next node. So in the end, we just return true if we can find a match. Because in this case, it does not have to be the end of a complete word. So in this case, if we find all the characters in this prefix match, we can just return true in the end. So this is our code. Let's try running. This solution has been accepted.